Hello guys, today we are going to look at how I solved the mass consecutive ones problem on LeetCode. It was a problem I encountered after taking the introduction course on the learn section of LeetCode. So I went through what is an array, assessing elements in array, and then array capacities versus lengths, and arrived at this problem, which I used the knowledge I acquired to solve that problem. So the problem states that, let's say you have an array of ones and zeros. So you want to determine the maximum number of consecutive ones. So in this instance, we have the consecutive ones is 2, so 1, 1, we have 2. Then we have 1, 1, 1, so over here we have 3. So the maximum of these two is 3, so you output 3. Another example is in this sense. We can see the maximum consecutive number of ones is this guy over here, so our output is 2. So let's look at the various submissions that I made and the one that and look at the running time of all of them. So this was the one that I did on my own from scratch. It's one of the codes that surprised me because the first time I ran it just worked, and that came as a surprise. So first I declared two variables. One is mass ones, which contains it's a variable which will contain the maximum number of ones. Then we have ones which hold the current number of consecutive ones that we have. Then I use a for loop to loop through the array of numbers. During each iteration, I check if the number is not 0. If the number is not 0, then I increase the current consecutive number of ones by 1. Then in that same if condition, I check if the current consecutive number of ones we have is greater than the maximum number of ones. If it is, then I set the current consecutive number of ones to the maximum number of ones. Now, anytime we meet a value that is 0, what we do is we just set the current consecutive number of ones to 0. So this loop will run until the end, until all the items have been iterated through. So this logic should give us the maximum number of ones. So I submitted it, it got accepted. The running time over here, it says your runtime beats 85.38% of Python submissions, which I think is quite okay. And then the memory usage is over here, it beats 98.70%, which I think is a cool algorithm. So later on, I went to search on YouTube for other ways of solving this same problem, and I arrived at different ways. One of the way I found was somebody used the mass function over here to determine if the current consecutive number of ones is greater than the maximum consecutive number of ones. Over here, I was doing it like this. So this code over here is basically does the same thing as this one over here by using the mass. So I ran this to see if it will improve like the runtime, and surprisingly it didn't improve it. Over here I'm having your runtime beats 23.64% of Python submissions, but over here just by changing that same line over here I'm having 85.3%. So I thought the inbuilt function, that mass function, will run faster than the normal this if statement that we have, but it seems the if statement beats that. Okay, and the memory distribution is like I just beat 50.14%, whilst this guy over here is like 98.70. Okay, so the last bit, I also looked to solve the problem in another way. This one, the way to solve this problem is first by converting all the numbers to strings, and after converting the numbers to strings, you join all of them together to form a one string, and then you split the strings by 0, so that we'll now have a new array which contains only list of like ones. So let me see if I could, let me just edit it over here. So we'll have something like a string like this, 111 then we have another 1 1 1, then we have another something like this 1 1 1. So this is an example of what we have. So we would have split the string with zeros, so we'll have a new array like this. Now all that we have to do is we use another function called the map. So we get the length of each string, and after getting the length of each string, we use the mass, this mass function, to determine the maximum length in that list. So when I was able to execute it, when I ran it, surprisingly, I thought it would be faster, but they say it beats only 13.71% of Python submissions, which means this first approach it performs much better than it. I don't know, maybe if this solution will shine when it comes to maybe more when the number increases or something. Okay. So one thing that came to mind is maybe it's because I've separated the steps into variables and all that. So what I did was I changed everything into a one-liner over here. But when I ran it, I also got the same results. Like the performance is just be 17.93%. But this is a cool one-liner, I think. Okay, so that's it for today. Maybe see you guys another time.